Hi there, and welcome back to section 2 of our discussion on perfect examination questions on business statistics. So, today's your first time. Do what to like, subscribe, comment, and share the video as well. So, you're going to begin from question number 26 to 50. Starting from question 26. If a final examination in a course is weighed 3 times as much as a quiz, find the mean grade of a student if the student had a final examination grade of 85 and a quiz grade of 70 and 90. So that means that the final examination FE is weighed 3 times as that of the quiz examination. So if the quiz examination is weighed, say 1, that means that our final examination is going to be weighed 3. So therefore, to find the mean grade, we'll say that the mean grade is going to be the weight, all right? And that should be equal to the summation of the weight multiplying the x value, which is the grade, divided by the weight. So we'll have here as 3 for the final examination multiplying 85 plus 1 by the quiz grade of 70 plus another 1 or 90, all divided by So we have 3 plus 1, 4, and then we have a weight of 5. So generally, we're going to have here as 255 plus 70 plus 90, all divided by 5. So in summary, this is what we're supposed to have. I'm going to have here as 415 divided by 5. We're supposed to get 83.00 as the mean grade for this. So the correct answer is going to be 83. So here there was no option. Students are required to provide the option. So the answer is supposed to be 83. Question 27. A construction company pays its hourly employees 6,500 Ghana cedis, 7,500 Ghana cedis, and 8,500 Ghana cedis per hour. There are 26 employees, 14 are paid 6,500, 10 are paid 7,500, and 2 at a rate of 8,500. What is the mean hourly rate paid the 26 employees? So here we have the hourly rate, or we have the hours, and then we have the hourly rate that has been given. So straight up, we can say that the mean hourly rate is going to be more like a weighted kind of mean. So have in here straight up as where we have 14 are paid 6,500. So 14 multiplying 6,500. Okay, plus then we have 10 being paid 7,500. Then lastly we have 2 being paid 8,500. So when you have this and divide by the total hourly rate that we have, the hours, so 14 plus 10 plus 2 supposed to get 26 as the question actually informed us. So that means we're going to have here as 91,000 for the first 14 by 6,500. Then second one here we'll have 75,000. Then the last one will have 17,000. All divided by 26. And then we're supposed to have a total figure of so in terms of division, one is divided, we're supposed to get or a final answer, a total figure of 7,038 points, say 2 decimal places, 4, 6, our final answer. So whatever you get in 2 decimal places, you run it up. For currency is supposed to be in 2 decimal places. So let's take note of that. Now, looking at question 28 and 30, we have a preamble on top. So let's read the preamble before we start to answer from question 28 to 30. A class of 163 students wrote a quiz in business statistics. The least score was found to be 11. So the least score, so we have the least score or the lowest value to be equal to 11. And the highest score was So the highest value or the highest score to 86. Now let's go. It goes on to tell us that a group frequency distribution is to be developed for the performance of the students in the quiz. Use the information provided to answer question 28 to 30. So that means that the total summation of the class was given as 163. So we have what our n being equal to 163 as the total number of students in that particular business statistics or quiz class. So what is the requirement 28? Which, or it goes like, how many classes would a group frequency distribution have? That was a mistake though. So it's supposed not to be. Supposed to be how many classes would a group frequency distribution have? So by classes, then we want to find out what the number of classes supposed to have for the group frequency. So we use what we call the stages rule. So the stages rule, which is what step 3, supposed to be equal to, so just apply that number of classes. So XR stages rule should be equal to 1 plus what? 3.322, right? Log n to the base of what? 10. So you just have to apply this formula and we are good to go. So we have what? 1 plus 3.322. So our n is what? 163. So we have what? 163 to the base of what? 10. And we have log 163 to the base of what? 10. So I'm bring that up here. So log 160 to the base of 10. So when you compute that, supposed to have what? 8.349. Okay, so in a more approximated form, supposed to get a number of classes to be say 8 to the nearest whole. So 8 classes will do. So that becomes the total number of classes supposed to have for this data. So that was question 20. Then question 29. What would the width of each class in the group frequency distribution be? So to calculate the width or the class size is the same thing as the class size or the width. Okay, it's the same thing. It should be equal to what? The range divided by what? The number of classes desired. Number of classes. So number of classes. Okay, so let's go. Straight up, what do we get here? Here we will have what? The range supposed to be the difference in the highest value and then what? The lowest what? Value. So we take these two values, take the difference between the two, that will give us the range. So we'll have what? 86 minus 11 divided by the number of classes that we're supposed to have, or we got general up here. But here, I will advise that you go by using what? The decimal power, which is what? 8.349. And you're supposed to get what? 9.375. You can confirm that with your calculator. Okay. But when it comes to stages rule or when it comes to the class width issue, we always do what we call a rounding up approach. So rounding up means that once you have a decimal value after the whole number, that whole number will move to the next whole number. So here it's supposed to have what? The class width or the class size is supposed to be 10. So let's take note of that. That should be the answer for the class width. Then question 30. What would the lower class limit for the second class in the group frequency distribution be? So that means that here, in the question here, we're told that the lower value or the lower score, or the lowest score or the least score was what? 11. So that means we consider to construct the class limit right from what? The lower score or the lowest score rather. The lowest score was what? 11. So 11, we add 10 to it, supposed to get what? That means we're going to count 10, starting from 11. So 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. So means that from 11 to 10 I'm counting of 10, being the class size from 11, it will end at what? 20. And that means that the next second class limit will start from what? 21 to what? 30. And then the third one will start from what? 31 to what? 40. In that order, okay, till we are through. So let's take note of that. So we were told that what is the lower class limit for the second class in the group frequency distribution. So the lower limit supposed to, for the second class, supposed to be what? 21. 21. So we have here as the lower limit of this class generally up here. The lower limit is 21 for the second class. So let's take note of that. Question number 31. For a frequency distribution in statistics for 100 students, the arithmetic average was found to be 50. Later, it was discovered that Mark 64 was misread as what? 46. So find the correct mean. So that means that we have what? Our number of what? Or we have our frequency, which is supposed to be, so 100 students here, and we were told that the average score was found to be 50. So we can then find the average. That's x bar to be equal to what? N multiplying what? Multiplying what? Okay, we have already been given the average score. So the average score was what? 50. So we need to find the summation. So the summation is supposed to be what? So I'll say summation of what? Summation of the score supposed to be equal to what? That is the x bar, the mean multiplying what? N. So that should give us what? Yeah, 50 by what? 100. And we're supposed to get what? 5,000 here. So this was a total sum when one of the Mark 64 was misread as what? 46. So that means we need to correct that. So we'll say that here, this is what we're going to consider. The correct sum, I will use this summation x subscript c, being the correct sum supposed to be what? 5,000, okay, minus what? So the misread figure was what? 46. So we have what? 46. Then we add the original figure, was supposed to be 64. Right? So this is supposed to be the correct sum. And we're supposed to get what? A total value of what? 5,018. So once we get 5,018, then we can then find what the correct what means. So we'll say that correct mean x bar subscript c supposed to be equal to what? The correct sum, okay, divided by n. So what do we get? The correct sum was what? 5018 divided by 100. So we're supposed to get what? 50.18. So this is supposed to be the correct mean for this particular set of data. So let's take note of that. Now let's move on to question 32. But before we read question 32 and answer it, we have been given what? A data and a preamble to read as well. So the data above represent the highest speed of a sample of saloon cars. So here is a sample of saloon cars. All right. Use the data above to answer the next. So it's supposed to be the next 18 set of questions. So the following question: group frequency distribution in that line. So it's a group frequency thing that we're going to consider general up here. So let's see how we go, and then we flow with that. So using the stages rule, how many classes would this frequency distribution have? So before we can apply that, we need to know the total number of what? The data, in terms of frequency that we're supposed to have generally up here. So we have here 1, 2, in terms of the column form, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means each column will have what? A set of data consists of 10. Let's see the row. 1, 2, 3, 4, 5. So that means row is also 5. So 10 by 5, we get a frequency of what? 50. So that means our summation F, okay, should be equal to what? 50. So let's take note of that. So once we have that, then we can then apply our Sturgis rule right away without wasting my time. So let's say I will go with the Sturgis rule and then we flow. As usual, Sturgis rule, we have what? XR to be equal to 1 plus 3.322 log n to the base of what? 10. So we straight up apply. So we have 1 plus what? 3.322. So our total number is supposed to what? 50. So we have what? 50 to the base of 10. So what do we get in summary? Supposed to have a figure of what? 6.6 what? 4. But in a more approximated form, supposed to get what? 7. Most at times, I think I want to get a decimal part of the stages, the number of classes. In that way, we do what we call the nearest what? Whole. So if the decimal part is greater than 0.5, then you run to the nearest whole. But if it's less than 0.5, then you leave it to that whole, to the nearest whole in that case. You're good to go. So on approximation, you say that we're supposed to have what? 7 classes generally up here. So let's take note of that. That should be the answer for 32. Now question 33. What is the class size of the data above? So we are looking at the class size of the data above. So class size means that here we really want to know the class width. We want to know the class width. So how do we do that? So class width, let me compute that generally here. I'll say that my class width or class size supposed to be equal to what? The range divided by what? The number of classes that we have computed. So straight up, our range supposed to be the highest value minus the lowest one. So let's come back to the data and let's see. Among these data set that you see here, which of them is the highest? Let's run through. We have just 20 seconds to run through. So on a column by column basis, let's see. So throughout my looking at the data here, I can clearly see that the highest value here is what? 134. So I'll have here as what? 134. The lowest value is supposed to be what? And we can also check and see. Alright, so that will be the range divided by what? The number of classes that we have here. So the number of classes here, straight up, we're having what? 6.64, or you can even use a 7, depending on how you want to flow. But here, you can work it like that. So let's see what we get. Here, I had a figure of what? 4.857. So when it comes to the class, we do what we call a rounding up approach. So at any time we have a decimal part after the whole number, we run it to the nearest one. Okay. So let's take note of that. So here, rounded it up, supposed to get what? 5. So rounded what? Up, supposed to get 5, and you are good. So the class weight or the class size is supposed to be 5. So let's take note of that. So the class size supposed to be what? 5. It's supposed to be 5. So 5 as what? The class size or the width. Same thing. Now question number 34. Find the mean of the frequency distribution. So we are asked to find the mean of the frequency distribution. So since it's going to be a group data, as we are told here in bracket, group frequency distribution, we need to find what? Our frequency, find our values of x, and we can multiply by the frequency for us to get our summation f of x, and then divide by f. So we can write the formula straight up here. So we can say that x bar should be equal to what? Summation f of x divided by what? Summation what? F. So now let's go, but before we do that, let's have our construction of our frequencies, and then in that line we can flow with that. Okay. Or let's start with our class limit or the class interval. But we know the highest value is 130 and the lowest value is 100. So that means that here we can look at it from this line. We can have what? The first part we will have what? So I can have my class limit here. Okay. So for my class limit, I have what? 100 to what? 100 to. So the class size is what? 5. So that means we are counting 5 right from the 100 or starting from the 100. So 100, 101, 102, 103, 104 will give us what? A class size of 5. So that's from 100 to what? 104. And the next one is going to be from 105, okay, to 1009, and then from 1010 to 114, and then from 115 we flow to 119. All right, and then we do same. So let me also have another class size here because of my space. Just want to use this general tab here. So another class size, class limit rather, because we have been told that the number of classes is supposed to be what? 7. So we have 1, 2, 3, 4. So we are left with 3. So that means here to 122, 124. Then here from 125 to 129. And lastly, 130 to 134. Alright, so that becomes our class limits or the class interval. Okay, so once we have that, then we can then straight up move with what our frequency without even tallying. We can do tally as well, but we can straight up move with the frequency depending on the requirement here. We can straight move up to the frequency generally up here. So frequency, so we see how we flow with that frequency. So frequency, so I flow. So moving to frequency, let's see how we go with that. So we then have to come back to our table. So we are looking at what? The data that will fall in between what? 100 to what? 104. 100 to 104. So let's see how those data will naturally flow here so that we go. So let's start. So 100 to what? 104, first half. We are going to go on the column by column basis so that we can flow. Okay. Here we don't have any value falling between what there, but let's check the second column. We have what? 100 here. Okay. Then we have what again? So from 100 we move on to, so here I think we don't have any other data that will fall in between 100 to 104. But in the third column, you can cross check and clearly see we don't have any of that. Then on the fourth column, we have what? Let's see whether we have any value. So we have what? 104 also coming up here. And then I think that will be all for that of what? When you look at the last column, 2. No data falls within that. So that means that here we have a frequency of what? 2. You can straight up to write that general up here. Or better still, let me use the indication. So here is what? 2. For 100 to what? 104. Then we'll move on to the next aspect, which should be within a range of what? 105 to what? 109. 105 to 109. So let's see that also how that also goes generally up here. So 105 to 109. So we go in that systematical order. We look at it in a column by column basis so that we can identify. So from 105 to 109 we flow. So we can see that here we have what? 107 coming up here in the red. Then I think that will be all. Then we come back to the second column. We have 105. Okay. Then we have what? 108. Then what again? Then on the third column, I think you can clearly see that we don't have any falling between 105 to 109. But on the fourth column, we have 109 coming up here. We have 105 coming up here. 106 coming up here. And what again? I think that is true for the fourth column. And on the fifth column, we have what? 109. Then we have what? 105. Here you need to be a bit vigilant so that you can go through or scan the data one by one so that you can select all those data that will fall within the class limit to determine our frequency. So you just have to open up your eyes very well so that you can see the figures generally up here. So that means that on the red 2 we have what? 1, 2, 3, 4, 5, 6, 7, and then what? 8. We have 8 data coming up. That will fall within what? 105 to what? 109. So and straight up say that here is supposed to what? 8. Then, so you can clearly see the fire part we have what? 112. Then we have 110 also coming up here. That is on the first column. I think that is all. Then we come to the second column. We have what? 114. We have 112. I think that is all for that. And then on the third column we have what? 110, 114. That's 114. Another 114 here. Then we have what? 110 here. Then we also have here 111. And we also have here 112 also coming up. I think that is all for the third column. Then follow suit with the fourth column too. So we like to see what we have generally up here. That will fall within the range of 110 to what? 114. So we have what? Another 114 coming up here. And then on the fifth column, let's see what we have. We have 112 here. Then what again? What again? 110 here. Then we also have 113. Then 111. And we also have what? 114. So you just have to open up your eyes very well so that you can see the figures. So let's do the counting and we flow. So on the column by column basis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have what? Instead of that, what? 16. You can cross check and see it's what? You can clearly see that in between 110 to what? 114 is what? 16. So let's take note of that. Let's take note of that. So we can come in and write what? 16 here, and we are through. 16. Then we continue from 115 to what? 119 generally up there. So the same idea that we are using to flow in that line. So here too, we flow like that. 115 to what? 119. Okay, being the fourth class limit. So we start column by column basis as usual. So we have here 118. Then we have 117 coming up here. We have 116 also coming up. Then we have what? 116 also coming up here again. Then we have what? 118, another 118 here, 119, 115 also here, and then another 118. Then we move to the third column. We have 117. I think that is all for that. Then we can then continue in the fourth column. So we have 116, 115, then 117. Then on the fifth column too, we have, well, let's see what we have. We have 118, another 118 here, and I think we are through. So we count them on a column by column basis as usual. So 1, 2, 3, 4, the green ones, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Because of the number of data that we have, you need to be smart in examination condition so that you don't waste so much of time. Just have to be smart there. So let's take note of that. So here too we have what 15 coming up. 15. So in between what 115 to 119, we have what frequency of what, 15 coming up. So let's take note of that. Then we continue 120 to what 124. So here too we come back to 120 to 124. So the first column we have what 112. We also have another 120 here, another 120 there. Then on the second column we don't have any value falling that. Then on the third column we have 122 here and 120 there. Then on the fourth column we have 121 here. I think that is 4 here. Okay, another 120 there in the top here. And then on the fifth column, I think we don't have any. So we are going to count them column by column, the yellow ones. So we have 1, 2, 3. Then we have 4, 5, 6, and then what? 7. 6 and then what? 7. So that means what? In between 120 to 124, the frequency is 7. So let's take note of that, 7. Then, move on from 125 to 129. Let's see what we have in between that line. So 125 to 129. So in between that we have 125, we have what? The first 27, 127 here. Okay, as a circled one. What again do we have? I think that is all for that. Yeah, you can check and see. That is all. So that means we have here as 1. And then 130 to 134, I think only this that we have generally here, the crossed ones. So that means we have here to be also 1. So that becomes the frequency generally there. And that means our total summation of the frequencies supposed to give us 50 as we computed. Right? So once we have that, that is true. The next thing we want to do is to find what? Our x values, where you multiply the frequency by the x, then we get what? Our f of x. So that means we're going to have a column for what? X, then another x. So because this is a group data, to find our x, it becomes the midpoint values. Or remember that the midpoint values is going to be working generally up here. So let's take note of that. The midpoint values. So to find the midpoint is supposed to be what? The addition of the lower class limit plus the upper class limit divided by 2 for all the classes. That's what we're going to do. So we add 100 plus 104, we divide by 2. 105 plus 109, we divide by 2 till we exhaust the list. Okay. So doing that, the first x value being the midpoint is supposed to be what? 102. Okay, 102. The next one, that's 105 to 109, is supposed to have what? 107. Then the third one supposed to have 1, 1, 2. The fourth one supposed to have what? 1, 1, 1, 7. And the fifth one supposed to have 1, 2, 2. Then the sixth 1, 2, 7. And then the seventh one supposed to get what? 1, 3, 2. So actually, if your class size or class width is actually right, which is 5, when you get to the midpoint, you can straight up contrast. Having the final or having the first class midpoint, which is coming from the first class limit of 102, for me to get my next class midpoint, I just have to add 5 to the previous x value or the midpoint, and that will fetch me the next. So that means if I add 5 to 105, I'm going to get 107. Add 5 to 107, I'm going to get 112 in that order, without going through to add the class limits once again. So we do this where we have equal class size or class width. So let's take note of that. So that becomes the midpoint value. So that means you also need to have a column for f of x. Okay, so we have a column for f of x. All right. So a column for f of x. We're supposed to get that generally up there. So a column for f of x, so that we can then get the total and then calculate our mean. So here, frequency by what? X. So here 2 by what? 2 by 102. You're supposed to get what? A figure of what? 204. Okay. Then 8 by what? 127. 8 by, sorry, I say 8 by 127. So here you need to be mindful. I've arranged my class, my midpoint, and then the frequency. Just have to be mindful of it. So here 8 by what? 107 rather. Is 8 by 107. Supposed to have here as what? 8, 5, 6. And then here 16 by 112. Supposed to have 17, 92. And then here 15 by what? 117. Supposed to have here as what? 17, 55. Okay. And then 7 by what? 204. Here we're supposed to get what? 7 by 2, 0. That's 204. Yeah, I need to be careful here. 7 by 122 and not 204. 7 by 122, supposed to get here as what? 8, 5, 4. Okay. Then 1 by 8, 5, 6. Get the same thing as 8, 5, 6. And then lastly 1 by 132, supposed to get 132. Okay. By the end of the day, we find the total sum. The summation is supposed to give us what? 5,000, or let's say 57, 20. 57 what? 20. 57, 20 as our total f of x. You can cross check with your calculator and let's see if that is true. And you get the same thing generally there. So let's take note of that. So having we gotten that, then we can say that our mean should be equal to 5720, okay, divided by that of what? The f, summation f, which is what? 50. So you're supposed to get a value of what? 114.40. So that becomes the mean value for this set of what data that we are on the process of constructing the full set of, the variables. So that becomes question 34. Then question 35, you say, what is the frequency of the third class? What is the frequency of, so the frequency of the third class is supposed to be what? Here. So we see that the frequency of the third class, just have to do that comparison there. So the frequency of the third class is supposed to be what? Here, 16. You can clearly see that 16. 110 to 114, get frequency of 16. So let's take note of that. So frequency of the third class, frequency is supposed to be 16. That is what? The third class. That is the third class, so let's take note of that. Then, what is the median of the frequency distribution? So what is the median of the frequency distribution? So median in a group frequency, this is how we calculate median in a group word frequency distribution. So median are made supposed to be equal to what? The lower class limits of the median class, okay, or the lower class boundary, something like that, plus n over 2, right, minus what? The cumulative frequency of the median class. That is the frequency that comes before the median class. We find the cumulative value and then divide by the frequency of the median class, and then all multiplying what? The class what? Size. All multiplying with the class size. The class size I say what? C. So that means you have a column for what? Cumulative frequency, right? And then also you have a column for what? Class size. Or you already know the class size to be 5, so having a column or not having a column, you are good to go. So we need to produce a column for what? Cumulative frequency. Okay, so that we can then flow. But the L1 here also represents what? The lower class boundary of the median class. So we also need to have what? A class boundary also coming up generally. So let's see, class boundary here 104 taken from 105 is supposed to get 1 divided by 2 get 0.5 as usual. So for us to get a class boundary, subtract what? The upper class limit of any class taken from the next lower class limit of the succeeding class. So for instance, 110 to 1104, the upper class limit is 114, taken from 115 being the lower class limit of the next class. Then we divide the result by 2. And once we get the common point, we add that common point to the upper class limit, and then we subtract that same common point from the lower class limit of all the classes. And that will give us our class boundary. So let's take note of that. So we want to have our column for class boundary. So we'll have our first column for class boundary, and then another column for class boundary to represent the next classes value that we have. So we flow. So the class boundary of 10, that's 100 to 104 is supposed to get what? 99.5 to 104.5. Then the next one, 104.5 to what? 109.5. Okay. Then 109.5 to 114.5. Then the next one is what? 115 to 119 is supposed to have what? 114.5 to 119.5. Okay. Then 120, so here's supposed to be what? 119.5 to what? 124.5. So you realize that the upper class boundary of a particular class becomes the lower class boundary of the next succeeding class. So we have what? 124.5 to what? 129.5. And lastly, we have what? 129.5 to 134.5. That's going to give us what? Our class boundary generally there. So let's take note of that. So once we have the class boundary, the next we want to do as per the median formula for group frequency, we need to have our cumulative frequency. So we have CF, alright? Another CF coming up. So let's see how we flow with that. So here too, CF means that here we're going to add the frequencies in a less than approach or in a less than method. So that means that here the 2 here is supposed to have a frequency of 2 already be written here. Okay. For me to get the next cumulative frequency, I'll add the 2 to the current frequency, and that will give me what the next cumulative frequency of say 10. And then cumulative frequency of the third class supposed to be what? The addition, alright? Supposed to be the addition of what the previous cumulative frequency plus the current frequency. So that will give me what? 26. That will give me 26 in that order till we exhaust the list. And then the next one is supposed to give me what? 41. Okay, and then here supposed to get what? For 120 to 124, cumulative frequency is supposed to be what? 48. Okay, and then here is supposed to be 49, and lastly supposed to have here as well 50. So for you to know that you are right when it comes to cumulative frequency, your last value of the cumulative frequency of the last are supposed to be equal to what? The total frequency. And here we can clearly see that it is true. The frequency is 50-50. We are true with that. So let's take note of that. So now we can then go back to our formula and then calculate our median generally up there so that we flow. So therefore, we can say that here to calculate my median, then I can apply straight up. So the median should be the middle value. So for us to get the middle value means that the middle value of the data. So that means we need to know the position generally up here. So median is is supposed to be what? 1 over 2, okay? 1 over 2 summation f. So what do we get? 1 over 2 multiplying 50. And that's going to give us what? 25th word position of the median word class. So go back and then be counting for us to get what? A cumulative frequency of what? 25, right? The class that we can get 25. So we can clearly see that here we have here 2 plus 8, 10, 10 plus 16, 26. So that means that the median value will fall in between what? 110 to 114. Or in between here, or within this class, we have a frequency even more than half of it falling within this, class limit of 110 to 114. Okay, so let's take note of that. So that means that the lower class boundary of the third class, which is 110 to 114, is going to be what? 109.5. 109.5. So we'll have here as what? 109, okay, 109.5 plus, and we apply. So here n is what? 50 divided by 2, okay, minus our, here the cumulative frequency of the median class is going to be the frequencies that comes before the median class, and that's supposed to be what? 2 and then 8. When we add it, we're supposed to get what? 10. Alright, that is the cumulative frequency preceding the median class. So it's supposed to be 10. So we'll have here as what? 10. And then divide all by the frequency of the median class, which is what? 16 generally here. Okay, 16. So we'll bring the 16 here. And then multiply all by the class size of what? 5. So as usual, you can punch them within that line. So here, 109.5 plus. So calculating all this on a calculator, you're supposed to get a value of what? 4.6875, and that should give you the median value of what? 114.1875. Now more 2 decimal place, we're going to get 114.19, or 4 decimal place, get this. So this is going to be our median value from the group frequency distribution here. So let's take note of that. So question 37, find the mode of the frequency distribution. So here, our mode for group frequency distribution is supposed to be equal to what? The lower class boundary of the modal class plus triangle 1 divided by triangle 1 plus what? Triangle 2, all multiplying what? The class size. So triangle 1 represents what? The difference between what? The frequency of the modal class and then the next previous what? Frequency. And triangle 2 represents the difference between the modal frequency and then the next succeeding frequency. So coming back to our table, we can see that the modal class, that is the most occurring set of data or values of frequency, supposed to be in the class limit of 110 to 114, which is what? 16 here. That's going to be our modal class, and then the mode frequency is going to be what? 16. So this is how we go. We will say that here the lower class boundary of the modal class is what? 109.5, since we have identified from what? The third class limit. So we'll have here as what? We'll have here as what? 109.5 plus. The first triangle is going to be what? The difference between what? The modal frequency, which is 16, minus the previous frequency, which is what? 8. Okay, so 16 minus 8, alright, divided all by 16 minus 8 plus. The next one is supposed to be triangle 2, which is what? Supposed to be 16 minus what? 15, being the next modal and be the next frequency, the succeeding frequency, and then multiply by what? 5. Okay, so we can clearly see that from here 15. So we subtract and then we are good to go. So straight up, we can say that here we will have 109, okay, 0.5 plus. So in computation of this, supposed to get a value of what? 4.44. So in summary, you have a mode value of what? 1113.944. So let's take note of that. So that's going to be our mode from the frequency distribution. Then question 38. Find the variance of the data. We are asked to find the variance of the data. So this is a group data. So to find the variance of a group data, this is how the formula goes. Supposed to be what? Summation. That is the alpha square is supposed to be what? Summation f of x squared, okay, divided by what? N, being what? The total frequency, okay, minus the summation of what? F of x, all divided by what? N, all square. So we realize that this is what? Just actually the mean. So we just have to bring the mean here and you square it again. So this is how you find what? The variance of a data. So that means we need to have a column for what? S squared and a column for what? F of x squared. Alright. So let's go back and continue with our table that we're building up generally here. We're gonna have a column for what? S squared, okay. So I have that first column coming up. And then another x squared column also coming up here. So we can have that also generally here. We can flow. Alright, so all that you need to do is to square what? The midpoint value, which is what? The x values that you see here. We're going to square them. So square of 102 is supposed to give us what? 10,404. Okay, the next one is supposed to get, you can check that with the calculator, 11,449. Okay, that's 11,449. And the next one is supposed to be what? 125,44. I mean the square of what? That is 112. Supposed to get what? 12,544. And then the fourth one, which is what? 117, supposed to get 13,000. So say 13, 689. And then we move on to the fifth, which is what? 122, supposed to get what? 14,884. Then we have what? Here to be 16,129, being the square of what? The x values. And then we have lastly 17424. So after doing this, the next thing you want to do is to create a column for what? F of what? X squared. We're going to create a column for F of x squared. So let's bring that up here. We're going to have a column for F of x squared here. I'm going to bring that up here so that we can flow. So a column for F of x here for all the data sets. So I have F of x squared. I'll continue my building up from here. F of x squared. Generally up here. So I have my x values. I'll bring it down here so that I can then multiply by their frequencies and I'm good to go. So that means we have 10,400 and what? 4 multiplying what? The frequency of what? The first frequency which was what? 2. You're supposed to get what? 20,000. Okay. 20,808. 20,808. Okay. Then the next one, 11449. That's 11,449 multiplying frequency of what? 8. Supposed to get what? 91,000. 91,592 in that order to years. So the third one is supposed to be what? 200,704. And the fourth one we have what? 205,335. Then the fourth supposed to have what? 104,188. Then the fifth one supposed to have 16,129. And the lastly we have here as what? 17,424. Here you must work fast. You must work fast. Like, calculator should be your guide to work fast. So it means that in finding the total sum, you're supposed to have a total sum of what? 656,180. That's 600 and what? 56,180. So this is going to be our summation of f of x squared. So therefore we can then come in and apply our formula saying that summation f of x squared is what? 656,180, okay, divided by the frequency of what? 50, okay, minus our mean. Here our mean or our f of x has been given as what? 570 divided by 50, but it's the same thing as the mean of what? 114.40. So I can just substitute what? 114.40 and I'll square it. That is all. So that means at the end of the day, supposed to have here to be what? 13,000 and what? 87.36 minus the square of the mean. So here supposed to be 13,123 with the help of calculator. Point what? Say 6 minus what? 13,087.36. That's the square of the mean. And it's supposed to have a value of what? 36.24. So that becomes what? The variance. That becomes the variance of the data. 36.24, which is the square of what? The data, generally there. So once we have that, then the next one we are asked to calculate is what? That of our standard deviation. So standard deviation is going to be the positive square root of the variance. So we'll say that standard deviation xd should be equal to what? The square root of what? The variance, which is what? The s square that we have, alpha square that we have. So we had what? 36.24. So we just have the square root of what? 36.24. And what do we get? Supposed to have what? A figure of what? Supposed to have a figure of what? 6.02 as our standard deviation. So let's take note of that. Then question number 40. What is the cumulative frequency of the fifth class? So that means we go back to our data and check. So the fifth class is supposed to be what? 120 to 124. So the cumulative frequency of the fifth class is supposed to be what? 48. So we have here as well 48. So let's take note of that. 48. If you want to see, I'll show it here. 48. Starting from here. 48. Here you can see the 48. I'm showing up here. This one. Okay. So that becomes the cumulative frequency 48. So that is that. So cumulative frequency of the fifth class, CF of the fifth class, supposed to be 48. Then 41. What is the third quartile? What is the third quartile? So third quartile means that we have what? 3 over what? 4 as the third quartile. So let's see how we go with that. So Q3 supposed to be the L what? Subscript 3. lower class boundary of the quarter class, okay, plus then we have in here 3/4 multiplying the frequency, which is n, minus what? The cumulative frequency that comes before the quarter class. We sum them up and then divide by what? The frequency of the quarter class, and then multiply that by what? Our class size. So that is how it goes when it comes to the quarter issue there. So that means that we need to find the position. So Q3 will give us what? 3/4 multiplying 50, okay, and that should give us what? Approximately, you're supposed to get 37.5 position. So that's how you're going to get, and we locate that. So 37.5 means we need to come back to our data and add the frequencies, and the class that will be able to help us after adding them from the beginning to the class that will give us 37.5, then that will be our class limit for the quarter, the Q3 being the third quarter. So let's see how it goes. So we have here as well. As usual, we have here. So let me erase this. Let me take off this so that we can. Oh, sorry. I think. Yeah. So let me take this off first. Oh, this was blue. Alright, so that means we have 2 plus 8, which is 10, plus 16, 26. So 26 plus 15, supposed to get what? 41. So that means the third quarter will fall within what? 115 to what? 119 as our class limit. Because the total is giving us 41, but what we have as quarter position is supposed to be 37 points. So that means to fall within what? 115 to 113. 119, sorry. So let's take note of that. So here we'll have what? Our lower class boundary of the quarter at the third quarter to be what? 114.5. So we just have to bring that up here. Just do the substitution and flow. So here is supposed to be 114.5, okay, plus. So here was what? 37. So straight up we had 37, right? 37.5 minus the cumulative frequency of that comes before the quarter class. So here the class limit has been determined as what? 115 to 119. So we just have to add the cumulative frequencies before the quarter class, right? Or before the quarter frequency. So here we add them. 2 plus 8, that is what? 10. Plus 16, you get what? 26. We'll get 26. So here that means the cumulative frequency is what? 26. So we subtract 26 from here. Okay, and then divide all by the frequency of the quarter class, which is what? 15. Okay, then multiply by our class size of what? 5. So we'll have here as 114.5 plus what? So here the whole of this is supposed to give you what? 3.833, and in summing them I'm supposed to get what? 118.33, and that will give you what? The value of the third quarter in this data set. So let's take note of that. Then, question 42. The class mark of the third class is the class mark or the class limit, the same thing. The class mark or the class limit of the third class is the same thing. So here it is what? 110 to what? 140. That's the class mark or the class limit. Okay. But notwithstanding, at times the class mark can also mean what? The midpoint. The class mark can also mean the midpoint. So once you identify the class limit, then the class mark, for me to get a common value or a single value, then we can also look at it in terms of what? The midpoint. So that means if you're also looking at it in terms of midpoint, it's supposed to be what? 112. Or if you are looking at it from the class limit approach, then 113 to what? 1114. So let's take note of that. So here we will have what? We will have 1102 1114, which is the same thing as what? 110 in terms of what? The midpoint plus what? 1114 divided by 2 is supposed to get 112. So if you are looking at it from the midpoint, then select this. If you are looking at it from the interval, then we select what X. So let's take note of that. Then 43, find the fifth decile. So this is a group data. Fifth decile means what? Half of the data was 5 out of 10. Decile is measured in terms of what? In terms of total, is out of 10. So fifth decile means you have 5 over 10, which is the same thing as what? 1 over 2. This is equivalent to finding what? The median. So let's go with that. So fifth decile, D5, supposed to be equal to the lower class boundary of the decile plus, okay, plus n over 10, okay, n over 10 minus what? The cumulative frequency of the decile class that comes before the decile class divided by the frequency of the decile class, okay, or multiplying with the class size. So we flow like that, and then we are good to go. So here, D5 means what? Half of what? The data, that's 25, right? So we flow like that, then we are good to go. So it's the same thing as the median value, so that's 1 over 2, okay? So that means that will fall in between here, 110 to 114, because here, when you find half of 50, you're going to get 25, and that is falling within what? This what? Class limit with a frequency of 16. So let's take note of that. So straight up, we can have here as what? The third, we are having here as what? 109.5 has been what? The lower class boundary of the third class. Okay, yeah. Then, plus. Yes, we will have here as what? We will have here as what? 25, which is what? 5 over 10 by 50. Okay, minus the cumulative frequency that comes before the median or the fifth decile, which is what? 2 and then 8, giving us 10. Okay, giving us 10. And then divided by the frequency of the decile, which is what? 16. Then multiply all by what? 5. So we get here as what? 109.5 plus. So when we find the total sum, we're going to get what? 4.6875. So in summing them, I'm supposed to get 114.1875. So D5 is the same thing as what? Q2, quarter, right? Or the median, which is the middle value, the same thing generally there. Question 44. What is the upper class boundary of the modal class? So we identify the modal class to be what? To be the third class, the most occurring data, which is what? 16. So we have been asked to find what is what? 44. What is the upper class boundary of the modal class? So upper class boundary of the modal class is supposed to be what? Here. It's supposed to be here, which is what? 114.5. 114.5. So let's take note of that. 114.5. 114.5. So the upper class boundary of the modal class supposed to be what? 114.5. And you are good to go. Then question 45. What is the fourth quartile of the frequency distribution? So here we are looking at 4 over 4 approach. So the same formula you work it out, and then you are good to go. So we're looking at it from Q4. So Q4 is supposed to be equal to the lower class boundary of what? The quartile plus. Here we're looking at it from what? 4 over 4 of what? N minus what? The frequency of the quartile divided by the frequency of the quartile. Okay, then multiply by the class size. So we flow like that, in that manner, and then we are good to go. So we have, so let's see 4 over 4 of the data. Supposed to get what? It's supposed to get what? The same as what? 50. 4 over 4 give us what? 1, multiplying what? It's supposed to get 50. So that means we're looking at it for the total frequency. So total frequency then, it means that for us to get the class for K of 4 is supposed to be the last class, which is what? 130 to what? 134. That will give us a total of what? 50 at the, as the position. I mean, as a position. So let's take note of that. So the 50th position that we are talking about here. So straight up, once we have that, that means that the lower class boundary of the last class, which is what? Class which is 130 to 134, supposed to be what? 129.5 as the lower class boundary. So we'll have here as what? 129.5, okay, plus. Then we have here as what? 4 over 4 by 50 minus, so the cumulative frequency is supposed to be 49. So we add all the frequency, because we were told that here the frequency of the last class was 1. So that means adding all other frequency is just what? 49. Divide all by the frequency of the Q4, right? So that is what? 1, okay. Then multiply by 5. So here we'll get what? 129.5 plus, we're supposed to get what? A value of what? 5. Yeah. And that will give us what? 134.5. So it is going to be the value of our Q4 in the group data. So let's take note of that. Then question 46. Question 46. The formula for class size is, how do you calculate class size? For us to get class size or class width, here if you have been given class size or class width with that option, you have two formulas to state generally up here. It can be the difference between the upper class boundary compared with the lower class boundary, or it can be class size, which is supposed to be what? The range divided by what? The number of classes desired. So the two formulas are supposed to give us the class size in that particular case. So let's take note of that. Then 47, what is the coefficient of variation of the data? So coefficient of variation, CV, supposed to be equal to what? Supposed to be equal to the standard deviation over what? The mean. So all multiplied by what? 100, general up here. So that means that here our standard deviation was computed to be what? 6.02. That's our standard deviation. 6.02. And our mean was computed to what? 114.4. You can cross check that and let's see. That was our mean there, here. So that means that here multiplying here by 100, supposed to get what? A value or a figure of what? 5 points. Or let me bring it up here. So our CV coefficient of variation is supposed to go 5.26%. 5.26%. So let's take note of that, 5.26%. So this tells us the proportion of what? Variation. That is this amount of data. In terms of percentage, it's 5.26. Right, so that is the deal for coefficient of variation. Then question 48, what is the coefficient of skewness of the distribution? So when it comes to skewness, we have what? Two formulas. The first formula is skewness 1 should be equal to what? The mean minus what? The mode divided by what? The standard what? Deviation. The first formula is used where we have what? A strong mode value, or where we have a strong mode what? Value. That's where we use what? Or we have what? A strong mode value. Yes, that is the first formula, skewness. But the second formula, which is what? Second formula, which is SK subscript 2, which is 3 multiplying what? The mean minus what? The median value divided by standard deviation. Here it is used where we have a weak mode or we have multiples of what? Mode values. Then we will use the second form. So if we have a weak mode, I mean where the value of the mode is very small, or we have multiples of mode values, that's multimodal, then we go by the second formula, which is what? 3 times x bar minus the median over the standard deviation. So let's take note of that. So here you can clearly see that there wasn't any, multiple mode. And then when you look at them, what were we getting for the modal value generally up there? The modal value, what were we getting for that? We were getting what? 113. So compare this against that of the mean, which is 114. The mean is greater than the mode. So we can naturally say this is a weak mode. So we can go by what? The second formula. Or better still, you can compute the two. Because we are not doing analysis here, you can compute the two and then have them generally up there. So let's compute the two as just a way to, flow with the formula. So here we have our mean of 114.4 minus the mode figure of what? 113. What was the figure for that? We're getting what? 113.944. Okay. 944, all divided by the standard deviation of what? 6.2. 6.02. And we do same here. Here too. 3 by the mean of what? 114.4 minus the median value. What we're getting for the median value? Median value was what? 114.1875. So 114.1875. Okay, all divided by what? 6.02. So what do we get for the first? What do you get for the second formula? So the first one is supposed to get what? 0.0766. And then the second one is supposed to get a value of 0.1059. So 3 decimal is supposed to get 0.10, say 6, something like this. So that becomes the skewness of the two, and then you are good to go. Then 49, the data is, so here they are asking based on the skewness, the data should be what? So here, for skewness of a data, if the value of skewness is positive, then it's what we call a right skew distribution. If it is negative, then it's a negative skew distribution. If the value is 0, then it is what? Symmetrical. But here it was positive, so we say that the data is what? A right skewed distribution, or a positive or skewed distribution. You write that and you are good to go. So let's take note of that. Then 50. Find the mean deviation for the data. Find the mean deviation for the data. So here to find the mean deviation of the data, MD for group data, MD is supposed to be equal to what? Our sigma F multiplying what? The deviated values of x minus x bar, okay, all divided by what? The summation F. So we need to produce a column for what? X minus x bar, then x minus x bar multiplying F. So we need to have a column for that, and we are good to go. So let's use the F values, and then let's bring it up here, then we multiply. So let's do the deviation, then we flow. So we have x minus x bar, okay, then another x minus x bar. Then we do our f of x minus x bar here. Then we have another one, f x minus x bar. The vertical bars represent the absolute values, okay. Okay, so we flow like that and we are good to go. So the x represents what? The midpoint. So we can go and get our midpoint values. I think we can get our midpoint values somewhere here, or we have deleted that. So these are the midpoint values supposed to have. So we have 10 to 107. Let me build up here. We can go. So we have the first one, 102, okay, 107, 112, 117, sorry, This is what I'm doing. I mean, let me copy this. That's supposed to be the x values coming up. So let me bring that up somewhere here. Okay. Then we have also x. Then we have 1, 2, 2. Then we have 1, 2, 7. Then lastly we have 1, 3, 2. So you just have to deviate the mean of what 114.4 from these x values so that we are good to go. So the first deviation in its absolute form supposed to be in absolute bars. If it is negative, we get positive. That means the absolute. If it is positive, it remains positive. So when you subtract 114.4 from 102, you're supposed to get what? In its absolute, supposed to get 12.4. Here, supposed to get the next one is supposed to get 7.4. The third is supposed to get 2.4. Then the fourth one is supposed to get 2.6. The fifth one is supposed to get what? 7.6. Here is supposed to get 12.6. And lastly, supposed to get 17.6. So once we are through with the absolute values of the deviation, we then have to multiply that by their frequencies. So the first frequency was 2. So 2 multiplying this, the first 12.4 was supposed to get what? 24.8. And the second frequency was 8 multiplying 7.4, supposed to get what? 59.2. The third frequency was 16 multiplying 2.4, supposed to get what? 38.4. And the fourth frequency was 15 multiplying 2, supposed to get 39.0. Okay. Then the fourth frequency was what? I think it was 7. Yes, so 7 multiplying what? 7.6. Supposed to get 53.2. Then 1 multiplying 12.6, supposed to get 12.6. Under 1 also multiplying 17.6. You're getting 17.6 as the frequency. So once you have that, just have to have your summation of what? F of the deviation value. So let's see what we get. Suppose to have a total sum of what? 2, 2, 2, 2, 2, 4. No, it's supposed to be 244.8. 244.8. So that means we can therefore say that our mean deviation is supposed to be equal to 244.8 divided by a frequency of 50. And we're supposed to get what? 4.896. And we are good to go in 3 decimal places. So that becomes the mean deviation of the data. And that brings us to the end of part 2 of our discussion of business statistics practice question. So thank you for watching this video. Really find value out of this video. Please do all to like the video, subscribe and share. Most importantly, drop a comment. That will always encourage us to make a helpful tutorials videos to help assist you and to pass your examination going forward. Thank you for always joining us, and I'll see you in the next section. Bye-bye.